we want to solve a triangle, it means that we have to find all of the missing side lengths and all the missing angle measures. The rule of thumb that you must use is always use what is known. You always want to use what is known to actually calculate the unknown unless absolutely necessary. So that means that if you have things that are known in the beginning, you should not use anything that has been calculated unless you have no other choice. There are some minor exceptions with angles, but overall, you should always use what is known. We're going to be using the Pythagorean theorem, our primary trig ratios, and we're also going to use our understanding of how many degrees are in a triangle. Our first triangle, we're going to solve this one. Well, using just what we have, we can do anything really first. For example, if we want to solve for this angle, well, I'm going to call this angle theta. In relation to that angle, this would be our opposite, and this would be our adjacent. So our sine, sorry, not sine, tangent. Okay, so I'm getting ahead of myself. The only ratio that uses the opposite and the adjacent is our tangent ratio. So the tangent of our theta would equal our opposite side, when in this case is 7, divided by the adjacent side, which is 11. So in order to solve for our theta, we'd have to take the tangent inverse, just like we did in our section when we talked about finding angles. The tangent and tangent inverse cancel off, leaving us with theta being the tangent inverse of, I'm just going to change my colors, 7 divided by 11. And as we type that into our calculator, second tangent, 7 divided by 11, we have 32.5 degrees. Degrees being our unit. Now I'm going to call this theta 1 because we're also going to have to solve for the other angle, which I will call theta 2. This one will be theta 1, this will be theta 2. So our theta 2 in relation to our, in this one, this would be our opposite side. And this one will be the adjacent side. Meaning we're going to use our tangent ratio again. So the tangent of theta 2 equals the opposite side, which is 11, divided by the adjacent side, which is 7. We got our theta 2 by itself. We take the tangent inverse of both sides, making theta equal to the tangent inverse of 11 divided by 7. And when we type that into our calculator, tangent inverse of 11 divided by 7, we get 57.5 degrees. And there we go. Now you'll notice, if by chance we wanted to do this slightly differently, and I'm perfectly fine with angles. Side lengths I am not fine with. The total amount of degrees angle measures in a triangle is 180, which means if I took this 90-degree angle subtracted from it, and also took this first calculated angle of 32.5 away from it, we're going to get 57.5 degrees. So I'm fine with angles being calculated like this. You can find out one angle and use this property to find the other one. But I'm not fine with you using basically unknown things unless absolutely necessary. I do encourage and expect that you're using things that you actually have. Now, because I've calculated these angles, I'm not going to use these angles in order to find out what my hypotenuse would be, because that would be my hypotenuse, no matter what. And whether I'm referring to angle 1 or angle 2, it's going to be our hypotenuse. But because we have two side lengths, we can use our Pythagorean theorem, being a squared plus b squared equaling c squared. Doesn't matter what our a or b is. We've worked with our Pythagorean theorem since grade 8. And I'll just leave it as c. At the same time, I could call it h if I really wanted to. 11 squared is 121. 7 squared is 49. Yeah, I'll use h. (121) add 49 is 170. And that would equal our h squared. And finally, to get our h by itself, we take the square root. So h would equal the square root of 170. And the square root of 170 to the nearest tenth would be 13.0. I do try and be sticky with the fact that, yes, if I ask you to round to the nearest tenth, 13.0 is the correct answer. If you just have 13, you have now rounded to the nearest whole value. If I do ask you to round to the nearest tenth, I do expect that you have a tenth unit in there. Our final measuring unit is in centimeters. So angle 1 is 32.5, angle 2 is 57.5, and this hypotenuse is 13.0 centimeters. That has now solved the triangle. We have solved for every single unknown. This is already 9 degrees, this is 11, this is 7. We have every other unknown in this triangle. And for our other example, we're going to do a few things. For example, just like I said before, we can use the angle properties. In a triangle, there's 180 degrees. If I subtract away my 90-degree angle, and I subtract away my 39-degree angle, we get 51 degrees. So this theta would equal 51 degrees. Even though 51 comes out really nicely, we're going to stick with using our known angle. In relation to our known angle, this is our opposite. This is the adjacent. And in a right triangle, our hypotenuse is always across from the right angle. So if we have our opposite, and say we want to find out our adjacent, opposite and adjacent uses a tangent ratio. So the tangent of 39 would equal our opposite, which is 9, divided by the adjacent, and I'll use the letter A. It doesn't matter to me whether you use cross multiplication or manipulation. Last section, I had done a bit of cross multiplication. This one, I'll just do strict manipulation. Because I can cancel off my A's. And then I'd have A multiplied by the tangent of 39 equaling 9. And finally, get the A by itself by dividing by the tangent of 39. Of course, what I do to one side, I have to do to the other. Oh, sorry. Those will cancel off. leaving us with A being 9 divided by the tangent of 39. Therefore, when we type that into our calculator, comes out as 11.1, and our unit is meters. Even though we have these two sides, we're not going to use our Pythagorean theorem because 11.1 is a severely rounded value. We're going to use our 39 and our 9 again. But in this case, we're going to solve for that hypotenuse. The relation that uses the opposite of the hypotenuse, so not relation, ratio, is the sine ratio. So the sine ratio is 9 divided by the hypotenuse. And again, well, I did this one by strict manipulation. I'll show this one by the cross multiplication. 1 times 9 is 9. H multiplied by the sine of 37 is 8, or sorry, not 37, 39. Will be H sine 39. Divide both sides by the sine of 39. That will be canceled off. And H would equal 9 divided by the sine of 39. Meaning H equals 14.3 meters. And that is how we solve triangles. Now go have fun.